Hi, I'm John Licata, Chief Energy Strategist of Blue Phoenix. Blue Phoenix is a knowledge lab focused on the future of energy and the technologies and companies that will literally power our future. And today I'm continuing my series with Mercenary Geologist himself, Mickey Fulp. Mickey Fulp joining us today from Vancouver. Hey, Mickey, how you doing?
I'm doing very well, John. Good to see you again.
Likewise, I'm glad to be continuing this long chat, really about really uncovering the industry when it comes to the nuclear power and addressing some points that both investors and those curious about nuclear power seem to get a little bewildered. One being the safety of nuclear power. That's where I certainly want to continue our chat from last week. Mickey, every time I talk to somebody about nuclear power, they get so scared about the safety, the radiation ramifications. How is that ever going to change? How do we change public perception?
Well, I think we just need to educate the public. You and I, being nuclear energy veterans, if you will, we understand that nuclear power is absolutely the safest energy, baseload electrical power we can develop on the planet. There, over the course of what now, almost 60 years of nuclear, if you will, and about 55 years of that since electricity was first produced in a nuclear power plant. The record has been exemplary, really. I mean, we've had some accidents, but the number of people that have been affected, and especially in North America, is minuscule, especially and compared with other energy sources, nuclear is by far the safest.
Let's talk about the accidents. I mean, obviously, we saw Three Mile Island, Chernobyl. We saw what happened with Fukushima. But most people don't. I guess when they hear about the accidents, I don't know if it's the media that portrays it as the end all by all. It's the Armageddon when it comes to nuclear. But most people don't realize that when it comes to fatalities, it's really not the case. Can you just go a little bit into detail about what's been happening with these accidents and the real numbers when they're talking about any casualties or deaths related to the nuclear disasters?
Well, in the United States, we have had a couple of nuclear accidents. The first one was a test reactor with the military that exploded in Idaho, if memory serves, somewhere around 1954, 55, something like that. Three workers were killed. And that's been the sum total of all the fatalities from nuclear accidents in the United States.
Compare
Nuclear
that to I mean, look
power.
at the pipelines, Mickey. Look at the pipeline accidents. Look at the rigs, the accidents that we've seen,
Absolutely.
the BP Horizon. Like, that doesn't get the same sort of media attention. Granted, what happened with BP off the Deepwater rig, that actually had everybody watching. However, nuclear seems to, the globe focuses on that and looks at the negative aspects of that. What are people missing? Why is it that it's when it comes to nuclear versus a natural gas pipeline disaster, an offshore rig disaster? Why is it that nuclear is pigeonholed as the real enemy when it comes to the future of energy?
I think we are faced with a legacy, and that legacy is two atomic bombs dropped on Japan in 1945 that destroyed two cities, Hiroshima and Nagasaki, and that was the first way that nuclear energy was used. It was used as bombs, but since then there have been a total of three people killed in the United States, and that happened a long time ago, and that was human error
Yeah.
when control rods were pulled out of a reactor, and it went critical in 4 milliseconds. No one died at 3 Mile Island, and it took a long time for people to realize that 3 Mile Island was a very minor incident. It had a radiation release. Those things are never good, but in reality, the only nuclear accident that caused major fatalities was Chernobyl, and that was a very poorly designed reactor that had no containment vessels, and it was during the Soviet era, and they tried to cover it up, and it killed numerous people. The latest incident, Fukushima, no one died from these explosions and the partial meltdown of those reactors. It certainly was not a good situation, but something on the order of 25,000 people died in that tsunami, and
Absolutely.
and none of those people died from radiation exposure.
Let's just talk. Let's just focus a little bit more on Fukushima. Most people obviously believe that that maybe this could have been handled very differently from the nuclear company involved. However, let's just say it how it is. We had a natural disaster, a double whammy, an earthquake and a tsunami. The reactor that was built actually did its job. It did actually withstand the magnitude over 9.0 quake that actually hit. So from a design perspective, it actually did its job. But I mean, we're talking about a double natural catastrophe that I think often gets overlooked. So when we hear about what happened in Fukushima, most people completely forget that there actually was a tsunami. Again, that goes back to the nuclear being played up in the media as something that is a menace when it comes to the future of energy. So I just want to switch gears if I can, because technology is certainly playing a humongous role in a new form of nuclear power, new forms of ways that this is hitting mainstream. We're seeing innovation taking enormous move forward. The evolution of the small modular reactor started to be more and more funded by the U.S. government, companies like Babcock and Wilcox, companies like NuScale Power. That they're actually moving forward with that. Recycling. Let's talk about recycling a little bit, because this is something that the United States doesn't do. However, when we look at other countries, China, Japan, and even some countries in Europe, they actually do recycle, yet we don't. Why is that?
I'm not really quite sure. We've made the decision to not recycle. Those decisions were made quite a long time ago. I think a lot of that has to do with the United States' position from the get-go in nuclear power, and that was to provide plutonium to build more atomic weapons. Like you say, France is the leader. They reprocess lots of nuclear fuel, something on the order of 5,000 tons a year, if memory serves, and they supply about 75 to 80% of their power comes from nuclear. We have made the decision a long time ago not to reprocess, and in my mind, we are missing out on the boat in that regard, because by reprocessing nuclear fuel, you can generate 20 to 30% more energy with uranium and plutonium. And by reprocessing, you burn some really nasty what are called actinides, which are the byproducts of nuclear fission. You burn those up, so it's clean tech too. Reprocessing gets rid of waste, it gets rid of
Lower
the
waste.
really dangerous stuff, and you burn up more plutonium, which has additional benefits in the fact that you're preventing proliferation of plutonium, which is used to trigger atomic bombs.
So let's just clarify that for the people watching our conversation today. You mentioned France. France has over 75% of their power coming from nuclear, versus the United States, which only gets about 19% of their power from nuclear at this time. But it should be, you would think, growing when we start talking about carbon and how we're going to win the war on carbon. Let's hold that part to put aside.
Yeah.
If we are actually going to use waste as a catalyst for fuel when it comes to nuclear power, the amount of waste from producing nuclear power is going to diminish. We could potentially use the waste. From what I have been researching, waste can actually fuel the entire United States for nearly 1 century. Yet we haven't been moving forward on this. As you know, I had a conversation very recently with former U.S. Energy Secretary Spencer Abraham, And I asked him point blank, like, what's going on? What are we not using? And he make a really good point that, people don't want Yucca Mountain. They don't want us to store it, the waste, but they also don't want to move forward and embrace it as a potential. So from policy perspective, I think it's kind of insane that we're not actually moving forward with this, and I think we're missing out on a huge opportunity to throttle forward, now bringing that conversation with carbon, at a time when we can actually be moving forward in a more clean environment. Mickey, what is everybody missing when it's coming to this?
It's become a political football in the United States. It gets thrown back and forth. I have no good explanation why we will not embrace reprocessing. We are falling behind other parts of the world. France, England, Russia, Chinese, the Japanese are all starting work on reprocessing, and meanwhile, in the United States, we're at a standstill with it. I think it's quite unfortunate because, as you point out, we can supply about 50% from research I have done recently. About 50% of the power that we currently generated, if we reprocess, we could supply half of our needs right then and there, and that also enables us to conserve our uranium in the ground. You know that, John, the United States is very well endowed in uranium. Unlike other parts of the world, there really are no good deposits in Russia. There are no good deposits in China. We are sitting really on the catbird seat with some of the best uranium deposits in the world. So if we could reprocess, then that preserves that resource for the future, and is something that I feel like should be done, but I can't. You need to talk a guy like Spencer Abraham, and I did see that conversation you had, and it was wonderful. He's the guy with his thumb on the pulse of what goes on in Washington.
Thank you for that. You just said that the quality of the uranium is actually better here in the United States. I find that fascinating because just say what happened with the megatons to megawatts program out of Russia, which it did end in 2013. The United States only produces about 4 million pounds of uranium, yet we use about 55. So we're not getting it from Russia. We're not making more of it here. We don't have a great pulse on policy when it comes to recycling. Aren't we shooting ourselves in the foot when it comes to what the potential to be energy independent?
Well, absolutely. We are increasingly becoming independent of oil imports, and certainly we're going to be a natural gas exporter at some point. But the real Achilles heel right now, as you say, we produce something on the order. We might make 5 million pounds in 2013, but with the price that'll go down this year. So basically, well less than somewhere 7 to 9% of our needs. We import a lot of uranium from Canada, our friends to the north, who have some of the best deposits in the world. We import from Australia, very good deposits in Australia. But increasingly, we will become dependent on countries that are not particularly friendly to the United States.
That's a great point. That's a great point, Mickey.
Russia, Ukraine, Uzbekistan. Those are countries. Niger are countries in the top 10 uranium producers, and I just named 5 countries that are either unstable or not friendly to the United States.
So okay. When the conversation moves forward related to nuclear power, we talk about safety of uranium. Maybe what should be added to the conversation should be national security safety as well, because now we're talking about looking at potentially, doing more business with countries that, let's call it like it is, don't like us very much, and now we're starting to, as you mentioned, export maybe a little bit more oil, something I actually was talking about the other night on CNBC, and I don't agree with that, but hold that for a second. Well, let's stay with the safety argument right now. So maybe this is now a national security issue that we haven't really looked at when it comes to nuclear power. Throw in there cybersecurity, which is now everyone's concern when it comes to energy infrastructure, and the dedication towards looking at what the heck is happening with nuclear power. seems like it needs to explode and embrace. Um, Sticking with the safety, Mickey, this week was really interesting with some new developments. But I saw some news out of EPRI, Westinghouse, the University of Tennessee and Illinois, talking about accident-resistant fuel. Do you have any thoughts on this?
Well, yeah, there is continual research going on at universities in Westinghouse and to develop new fuels, the mixed oxide fuels, the recycling, and the idea that we can make better fuels for nuclear power. You throw in thorium in that mix too. So thorium's probably a subject that can stand alone in another show we
Sure,
do.
we'll definitely revisit
but
that.
a thorium reactor is you've got to keep bombarding it with neutrons, and as soon as you turn off the neutron flux, the reaction stops. So it can never go critical. So there are lots of research initiatives going on. And John, it's amazing because most of this technology was developed in the 1950s, and we just left it behind. So we have the small modular reactors, we have the thorium input into a metal, a uranium thorium metal fuel rods. We have the various other initiatives, the floating plants, the idea of having no pumps in a water cooling system, so it basically operates on gravity. So lots of initiatives to improve safety of nuclear power, and it's amazing because all this technology came right out of the 50s, was lost, and now is being developed again.
I mean, it's fascinating because we're really talking about innovation, and the sector is being iterated. Something Steve Jobs actually was extremely successful with Apple, but we're seeing the nuclear sector be iterated thanks to more open-mindedness about innovation and using that technology to go forward. Sticking with Westinghouse, because you mentioned Westinghouse, and I brought them up as being part of that accident-resistant fuel. But just today, Mickey, and I know we didn't talk about this, but just today, I actually read that they're actually moving forward with Toshiba about creating an AP1000 design that could actually withstand earthquakes. They could put them in areas that do have seismic activity. It's interesting because one of the knocks on nuclear power here in the country is the location of where the reactors actually are. If Westinghouse and Toshiba say, hey guys, put it where you want, it's fine to go near fault lines, isn't that another major positive for the sector?
Well, I think that is a positive, but being a geologist,
The
it would not be
mercenary
my
geologist.
yeah, the mercenary geologist. It would not be my choice to build a nuclear power plant on a fault.
And I'm not suggesting that they do. I guess reading with the release was that it can. And I know that's big. That's a big statement that if that does tend to work, but people get scared about the realities of these reactors failing. If that reality was put to the test and it actually was improved, shouldn't it make people feel a little better?
Well, yeah, and we have since the incident at Fukushima, we've tightened up and we've developed new technologies to make nuclear power plants more earthquake proof. Thing that intrigues me, and I'm gonna switch subjects here a bit, were these floating nuclear power plants. And they make all the sense in the world. You basically put a floating nuclear power plant in the ocean, and that becomes the ultimate tsunami and earthquake-proof regime because you have the ocean as a buffer. So where would you rather be in an earthquake? You would like to be offshore in deep water. So there are initiatives being developed. We have all this oil and gas rig technology with stable platforms. You moor the things on the ocean. When they reach the end of their useful life, they can be towed back to land and dismantled. And they are particularly interesting for very remote parts of the world. The Russians are going to have one producing electricity here within the next year or so, and they have plans to build a fleet of 10 of these. So people may think, oh, a floating nuclear power plant, that's new technology. We first did this in the Panama Canal.
Absolutely.
The technology was developed in the late 50s and early 60s, and the Panama Canal Zone was supplied by a floating nuclear power plant on a retrofitted World War II ship from 1968 to 1975.
I mean, and that's a great point. For distinction for those that are watching and referring to Panama, that certainly was more that it was in the water, but it was via port. Whereas these new technologies are going to be offshore completely, not just tied down, and that's not something that's just being moved forward in Russia. Here in the United States, MIT is actually moving forward with a lot of, I guess, go back to iteration of the idea of the floating reactor. So I think that's really interesting. You and I could go on and on. I mean, this is great that we're able to talk about this, and I love that. So we'll end it here for today, but promise me you're going to come back because we have to continue this conversation.
John, I think we could do this for quite a while, so I'm very willing to continue, and hopefully people are intrigued about what we're trying to do, and that's basically educate the public and educate especially people that are interested in nuclear power about the whole aspects and new initiatives and where do we go from here. And certainly it is in your opinion and mine, I know, the basis for baseload electricity in the medium to long term of the world.
Well, Mickey, this is great, and we'll definitely talk again very, very soon. Again, I'm John Licata, Chief Energy Strategist with Blue Phoenix. You can please feel free to follow me at Blue Phoenix Inc. on Twitter. And again, I'm joined by Mickey Fulp, the Mercenary Geologist. You can go on Mickey's website. I believe it's it's mercenarygeologist.com. Is that correct?
That's correct. I'm also going to put a plug in. We have a streaming audio 24/7. mercenarygeologist.fm, and the video or the audio portion of this interview will be in the rotation on it very soon.
That's great, Mickey. Mickey, thanks again, and we look forward to continuing this conversation.
I certainly do. Thanks a lot, John.
Okay, bye-bye.